Hello guys, sorry for the inconvenience produced in the last video in which voice was not coming after question number 36. So now in this video we will solve questions from 37 onwards. So the first question of this video is the most abundant volatile in magma is. So first of all you should know the abundance of volatile in magma. So the most abundant volatile in the magma is water, followed by carbon dioxide and then sulfur dioxide and then chlorine and fluorine. Okay, so the most abundant volatile in magma is water, that is H2O. Now let's check the options. First one is nitrogen, so this is not the most abundant volatile. Next is methane. Methane is also not the most abundant volatile. Sulfur and then water. So sulfur is the most abundant volatile in the magma, so the correct answer is water. Okay, now next question is the plutonic equivalent of phonolite is. So phonolite is volcanic rock, and now we have to tell the plutonic equivalent of this phonolite rock. Okay, so now let's check the options. So granodiorite, diorite, nephelinsinite and monzonite, all these are plutonic rock. To answer this question we should know the volcanic equivalent of all these plutonic rock. So first one is granodiorite. Volcanic equivalent of granodiorite is dacite, and volcanic equivalent of diorite is andesite. Volcanic equivalent of nephelinsinite is phonolite, and volcanic equivalent of monzonite is latite. Now question is asking about plutonic equivalent of phonolite, so the correct answer will be nephelinsinite, as volcanic equivalent of nephelinsinite is phonolite, or you can say plutonic equivalent of phonolite is nephelinsinite. Now if this question were asking about plutonic equivalent of dacite, then the correct answer would be granodiorite. If this question were asking about andesite, then the correct answer would be diorite. And if this question were asking about latite, or you can say plutonic equivalent of latite, then the correct answer would be monzonite. But this question is asking about plutonic equivalent of phonolite, so the correct answer will be nephelinsinite. Now coming to next question. Next question says, which one of the following contains silica in its composition? So to answer this question you should know the composition of all these four minerals, that is magnetite, spinel, sphene and ilmenite. Okay, so composition of magnetite is Fe3O4. This is iron oxide and it is a most important ore of iron. Next is spinel. Composition of spinel is MgAl2O4. Next is sphene. Sphene is also known as titanite because of its titanium presence in this in its composition, and the composition of sphene is CaTiSiO5. If you will break down this, then you will get calcium oxide, titanium oxide and silica. Okay, and if you will break down this composition, you will get Ab2O4, or you can say FeO and Fe2O3. This, if you will break down this, you will get MgO and Al2O3. And next is ilmenite, and composition of ilmenite is FeTiO3. That is, if you will break down this, you will get FeO and TiO2. Now question is asking about which one of the following contains silica in its composition. So you can easily see that in magnetite there is no silica present, in spinel there is also no silica present, in ilmenite there is also no silica present. Silica is only present in sphene, so the correct answer will be sphene. So to answer this type of question you should know the composition of all the minerals. Next question is, diatreme is associated with which of the following rock types? So first of all, what is diatreme? Diatreme are 1 to 2 kilometer deep, carrot shaped. Okay, carrot shaped bodies with circular to elliptical cross section. These have vertical axes which are steeply dipping sides approximately 80 to 85 degree, and they taper downward. See, these are broader in upward but they taper downward. Okay, and terminate into a root zone which is transitional to hyperbasal rock. And hyperbasal rock, now let's check the options. First one is granite, and you know granite is a plutonic rock. Next is diorite. Diorite is also a plutonic rock. Cometite is a volcanic rock. But kimberlite is a hyperbasal rock. And you know diatremes are transitional into hyperbasal rock like kimberlite and orangites. So diatreme are associated with, or you can say these are special features of, or you can say associated with kimberlite rock. So the correct answer will be kimberlite. Next question is, which of the following is a typical crustal mineral? So we have to tell that which of the following mineral, pyroxene, sterolite, olivine and serpentine, is typically found in crust. So first one is pyroxene. pyroxene, composition of pyroxene is MgFe whole twice Si2O6. This is ferromagnesian mineral and this is typically found in mental. Okay, next one is let's consider olivine. Olivine, composition of olivine is MgFeMn SiO4 Ca whole twice SiO4, and this is also typically found in mental rock pyrrhotite. Okay, pyrrhotite and pyrrolite. Next is serpentine. Serpentine is found in mafic to ultramafic igneous rock, and its composition is Mg6Si4 O10 OH whole twice OH whole 8. So this is also found in mental. Okay, but as far as sterolite is concerned, sterolite is the only mineral present in all these is which is typically found in crust. Okay, and its composition is Fe2Al9 Si4 O23 OH. Okay, and if you see that in serpentine you will not get aluminum, in olivine also you will not get aluminum, and in pyroxene also you will not get aluminum. Only in sterolite you will get aluminum. Okay, and this indicates its crustal occurrence. Okay, so the correct answer of this question is sterolite. Next question is Deccan volcanic province is mainly composed of. So Deccan volcanic province are large igneous province of west central India, and these are one of the largest volcanic features on the earth, and these are predominantly composed of thallitic basalt, and minor amount of carbonatite may also be present. But now let's check the options. First one is granite. Granite cannot be the correct answer because these are plutonic igneous rock, and the question is asking about Deccan volcanic province. So granite will be not the correct answer. Thallitic basalt, I told you that Deccan volcanic province are predominantly composed of thallitic basalt, so the correct answer will be thallitic basalt. Carbonatite is not the correct answer because in Deccan volcanic province these contain only minor amount of carbonatite, so these are not mainly composed of carbonatite. Okay, alkali basalt, though this was subject to debate for many years that Deccan traps are composed of thallitic basalt or alkali basalt, but later studies confirms that these are composed mainly of thallitic basalt. So the correct answer of this question will be thallitic basalt. Next question, question number 43 says that according to Bowman reaction series, the formation of olivine to biotite is gone by. So now let's check the Bowman reaction series. Okay, so this is Bowman reaction series in which you will see that there are two series, discontinuous series and continuous series, and a residual phase is present. Now this series, discontinuous series, include formation of minerals like olivine, pyroxene, amphibole and biotite, and this series is known as discontinuous because abrupt changes occur in composition when one mineral react to melt to form another, like say olivine react to melt and produce pyroxenes, pyroxene react to melt and form amphibole, and amphibole react to melt and form biotite. Okay, so therefore this reaction series is known as discontinuous reaction series, while the other one is continuous reaction series. This is known as continuous reaction series because plesioklase feldspar is continually present from calcium rich anorthite to sodium rich albite. Okay, and these are residual phases, K feldspar, muscovite and quartz. Now let's come back to the question, and question is asking about formation of olivine to biotite, and we have seen that formation of olivine to biotite is gone by discontinuous reaction, while continuous reaction involves formation of anorthite to albite. Decarbonation reaction involves removal of CO2, and it is not the mechanism involved in Bowman reaction series. And dehydration also, which involves removal of H2O, and this is also not the mechanism which is involved in Bowman reaction series. So the correct answer of this question will be discontinuous reaction. Question number 44 says that which one of the following minerals does not belong to a solid solution series? So first of all, what is solid solution series? It is a series found in a crystalline solid with composition that varies between specific in members. First one is feldspar. We have just discussed above that in continuous section series, plesioklase feldspar is continually present with specific end members anorthite and albite. So it forms solid solution series, and its general formula includes CaNaKAlSi4O8. Okay, so feldspar forms solid solution series with end members anorthite and albite. These form solid solution. But next is pyroxene. Now we know that orthopyroxene have end members in azurite and ferrosilite, and these form in a solid solution series. And also in clinopyroxene, it also forms solid solution series with end members diopside and Heidelbergite. Now coming to olivine, olivine also forms solid solution series with end members phyllite and forsterite. Now quartz, all the silica group minerals have SiO2 composition. Okay, so quartz is not the mineral which form solid solution series. So the correct answer will be quartz. Next question is ultramafic rocks are enriched in. So first one is platinum group of mineral elements. Platinum group of elements, also abbreviated as PGE, and are these are the among the rarest metals on Earth. And most of the world's PGE are concentrated in magmatic ore deposits, especially in ultramafic magmas. Okay, and if the ultramafic magma becomes saturated in sulfur, an immiscible sulfide liquid will separate from the silicate magma and form globules that naturally concentrate metals like copper, nickel, and platinum group of elements. So, platinum group of elements are concentrated in mafic to ultramafic rock. Now, next is alkaline earth elements. Alkaline earth elements are enriched in alkalic rock. Rare earth elements, these are enriched in acidic igneous plutons like pegmatite. Okay, and volatile elements are also not the one which are enriched in ultramafic rock. So, among these options, the correct answer will be platinum group of minerals which are enriched in ultramafic rocks or concentrated in ultramafic rocks. Question number 46 says that tidal bundle indicates. So first of all, what are tidal bundles? See, the formation of tidal bundles involve cyclic variation in thickness of forested lamelli due to effect of highest tides and lowest tide. Highest tide is known as spring tide and lowest tide is known as neap tides. Okay, so cyclic variation in thickness of forested lamelli due to effect of highest tides and lowest tide give rise to tidal bundles. That is, these are neap spring cycle. Okay, and thus it clearly involve tides. So tides are present only in marine environment. These are not present in glacial, neither in fluvial, and neither in desert environment. Tides are present only in marine environment, and tidal bundles indicate marine environment. Now, next question is Bauma sequence is characteristic of. So first of all, what is Bauma sequence? See, low to medium density turbidity currents form a succession known as Bauma sequence, and it is named after geologist Bauma who first described them. And now see, these are found by turbidity current which are low to medium density. Okay, and turbidity currents are most abundant in deep marine environments. So the correct answer will be deep sea deposits. Okay, neither in lake, neither in river, neither in glacial deposits. Bauma sequence is the characteristic of deep sea deposits. Next question says quartz arenite suggest. So first of all, what is quartz arenite? Quartz arenite is a type of sandstone containing greater than 95% of quartz fragments and less than 5% matrix. And we know that these are mature sandstone, so they must have gone through 2 or more cycle of sedimentation. Though these are also possible in one cycle of sedimentation, and the one stage of cycles of formation of quartz arenite in first stage of cyclic sedimentation is possible only in case of intensified tectonic activity at the source terrain. So the correct answer will be intensified tectonic activity. Now, tectonic stability of source terrain is not the condition responsible for quartz arenites, and active subsidence of depositional basis is also not the correct answer, and high sediment supply from the source terrain is also not the correct answer. So correct answer will be intensified tectonic activity at the source terrain. Okay, next question says deltaic facies sequence is. So deltaic facies shows progradation, that is deposition of sediment takes place from deeper, that is prodelta, to shallower portion, that is mouth bar. Okay, and the succession found by deltaic facies shows shallowing up pattern from prodelta to mouth bar, shallowing up. Okay, and in which the deepest water facies is pro-delta deposits, the deposit first having finest grain. Okay, and it is followed by delta front, then by the shallowest water facies, mouthwards, which are typically sandy or even gravelly. So it is clear that deltaic facies sequence is coarsening upward, like from finer particles in pro-delta to coarser particles in mouth bar. So this shows coarsening upward sequence. So the correct answer will be coarsening upwards. Finding upwards is not the correct answer, and or you can say not the correct condition for deltaic facies sequence. Fracturing upwards and folding upwards downwards are totally out of context of deltaic facies sequence. Now coming to next question. Process of early diagenesis occurs in. So early diagenesis occur at the surface or in shallow subsurface region, and it is responsible for much of the cementation of carbonate sediments. Now if you check the options sandstone, conglomerate, slates and limestone, you will see that limestone is having carbonate sediments. limestone is the rock which having carbonate sediments. These are not composed of carbonate sediments. Like see, sandstone is composed of arenites, and these conglomerate are composed of rhyolite, or and slates are composed of argillaceous. Okay, and this is basically metamorphic rock. Slate is a metamorphic rock formed by metamorphism of shale. So this is clearly out of okay context of early diagenesis. This is metamorphic. So the correct answer will be limestones. Next question is asking that fossils embedded in coarse grained calcite generate. Now, if you have read about full classification of limestone, you can easily answer this question. Let's see. First of all, fossil. The term used to indicate fossil is bio, which is present in almost all the options. So bio, and then coarse grain. The term used to describe coarse grain calcite is sperite. So bio. According to this question, the nomenclature will be biosperite. Now, first option is biosperite, and yeah, this is the correct answer, in which fossils are embedded in coarse grained calcite, and this texture formed by this is known as biosperite texture. Now, biolithite texture is found in that limestone which formed through in situ growth of carbonate organisms like coral reefs, and this is almost similar to boundary stone of Duhame's classification. So this is not the correct answer. Next is Biomicrite texture. Biomicrite texture is also from limestone classification, in which bio means fossil, and micrite means fine grained calcite. So these texture formed when fossils are embedded in fine grained calcite. Next one is pelmicrite texture. So pel means pellets, and micrite means again fine grained calcite. So pelmicrite texture forms when pellets are embedded in fine grained calcite. So as far as the question is concerned, in which question is asking that fossils embedded in coarse grained calcite generate biosperite texture. Now coming to next question. Next question says, in sandstones calcareous cement forms under. So see, in sandstone there are different type of formation of different type of cements, like calcareous cement, silica cementation, and clay cementation, and iron cementation. So alkaline conditions are responsible for calcareous cementation. Neutral conditions is responsible for montmorillonite cementation, which is also type of clay cementation. And the condition for montmorillonite cementation is approximately neutral to you can say alkalic. Okay, and acidic conditions is responsible for silica cementation in sandstone, and humid conditions is responsible for kaolinite cementation, which is also a type of clay cementation. So question is asking about calcareous cementation. So the correct answer will be alkaline conditions. Now next question says, large scale trough cross bedding forms due to migration of. So large scale trough cross bedding forms by aeolian ripples, and these are characterized by multi-directional ripples. Multi-directional. Now let's check the options. First one is micro ripples. Micro ripples is not responsible for formation of large scale trough cross bedding. Okay, 1D ripples are formed by unidirectional water flow, and these give rise to unidirectional cross stratification, or you can say horizontal cross stratification, but not the large scale trough cross bedding. Okay. Now 2D ripples are formed by bidirectional water flow, and these are responsible for the formation of bidirectional cross stratification like hummocky and swale cross stratification. So 2D is responsible for hummocky and swale cross bedding, but not for the large scale trough cross bedding. Now coming to 3D ripples, I have told you that large scale trough cross bedding are formed by aeolian ripples, and these are characterized by multi-directional ripples, that is 3D ripples. So these 3D ripples are responsible for the formation of large scale trough cross bedding. So the correct answer will be 3D ripples. Next question is, well sorted sediments explain deposition under. Now first option is fluctuating energy condition, second option is I think constant energy condition, third option is high energy condition, and fourth option is low energy condition. So see, sorting is dependent upon the energy condition. Okay, like say fluctuating conditions occur in stream deposits which are usually poorly sorted, because the energy in the stream varies with position in the stream. Okay, so fluctuating energy condition is responsible for poorly sorted, and it is found in stream deposits. Second one is constant energy condition. You will get constant energy condition in beach deposits and wind-blown deposits, and in both of these transporting medium, energy condition is usually constant, and these are characterized by well sorted sediments. Okay, so the correct answer of this question will be constant energy condition. Comment down below that which type of sorting is responsible for high energy condition and low energy condition. Next question is, arcoses contain more than. So what are arcose? Arcose refer to any feldspathic granite that particularly contains greater than 25%. Greater than 25%. This is the lower limit of feldspar, that is 25%. There must be 25% feldspar, then the nomenclature will be arcose. Okay, now let's take the options. First one is 35, this is not the correct. Next is second is 25% feldspar, this is correct. 50 and 60, these are also not the correct condition for arcoses. Okay, so arcoses contain more than 25% feldspar, much quartz and some rock fragments. Next question says, now metamorphic rocks of same species must have. So in metamorphic species, any rock or metamorphic formation must have acquired chemical equilibrium at constant pressure temperature conditions. So this is the condition prerequisite for rock occurring in a metamorphic species. So metamorphic rocks of same species must have, first one is similar whole rock composition. No, this is not the sufficient condition, or you can say prerequisite. Similar mineral composition, this is not, also not. Acquired maximum pressure condition, this is also incorrect. And acquired equilibrium under similar pressure temperature. From the definition itself, it is clear that metamorphic rocks of same species must have similar pressure temperature conditions. So the correct answer will be 4. Now coming to next question. Regional metamorphism takes place because of change in. So, regional metamorphism takes place because of change in both temperature and directed pressure or non-lithostatic pressure. So, now let's check the options. First one is heat alone. Heat alone is responsible for formation of contact metamorphism. Pressure alone is responsible for dynamic metamorphism. Hydrostatic pressure alone, this is also known as lithostatic pressure, and it is not responsible for deformation or any type of metamorphism. Okay, heat and directed pressure. As from definition of regional metamorphism, it is clear that regional metamorphism is produced by combined effect of heat and directed pressure. Directed pressure, this is also known as non-lithostatic pressure. Now coming to next question. Retrograde metamorphism in metapelites would transform. So first of all, you should know what is retrograde metamorphism and how does it take place. So retrograde metamorphism results from transformation of mineral from high grade to low grade. Like see, this is the sequence, okay, and this is the occurrence of index mineral with increasing grade. Like see, with increasing grade, chlorite is transformed into biotite, and biotite is from garnet. Garnet is into staurolite, and staurolite into kyanite, and kyanite into sedimentite. So this is the sequence of increasing grade of index mineral with, okay, in metapelites. Now, as far as chlorite is concerned, chlorite is stable not only in chloride zone, it is also stable in biotite zone, and in some sequences and in some consequences also it is stable in staurolite zone also. So now, first option is elementine to chloride. Now see, if the transformation of minerals takes place from higher temperature to lower temperature, this will result into retrograde metamorphism. But if transformation of minerals takes place from lower temperature to higher pressure temperature condition, it will result into prograde metamorphism. So first one is elementine to chloride. Elementine belongs to garnet. Elementine is a garnet mineral, and garnet zone is here to chloride. Chloride is here. So the transformation of elementine to chloride takes place from higher pressure temperature condition to lower pressure temperature condition. So this is an example of retrograde metamorphism. Now biotite to chloride. Biotite to chloride, if you see that biotite to chloride is also in this sequence, biotite to chloride is also from higher pressure temperature condition to lower pressure temperature condition. But since chloride is not only stable in only chloride zone, it is also stable in biotite zone, and also in some sequences it is also stable in staurolite zone. So from biotite to chloride may not be because of retrograde metamorphism. Okay, so this will not be the appropriate answer for this question. Now see, pyrope to fibrolite. Pyrope is also type of garnet, and fibrolite is fibrous variety of silimenite. So from pyrope to garnet, you will see this is transformation takes place from lower pressure temperature condition to higher pressure temperature condition. So this is a type of prograde metamorphism. Now sericite to fibrolite, you know sericite is a variety of mica, or better say muscovite, and fibrolite is fibrous variety of silimenite. Okay, so from sericite to fibrolite is also transformation from low pressure temperature condition to high pressure temperature condition. Okay, So this is also an example of prograde metamorphism, and the question is asking about retrograde metamorphism. So the appropriate answer will be element to chloride. Next question is, first name the rock that shows an intimate mixing of igneous and schistose material. So first of all, you should know about all these orthogneiss, paragneiss, litparlitgneiss and augengneiss, that definition of all these four rock. So first one is orthogneiss. Orthogneiss is composed of two words, ortho and gneiss. So ortho means of igneous origin, that is gneiss which is formed from igneous rock, metamorphism of igneous rock. Paragneiss, in para, this is para indicates the sedimentary rock of sedimentary origin, or you can say the gneiss which is formed from sedimentary rock. Lead parlite, these are injection gneisses, and from injection it is clear that these are formed by intimate mixing. Okay, and these are injection gneisses in which layered laminae are penetrated by roughly parallel igneous material. So question is also asking about the rock if it shows intimate mixing of igneous and schistose material. So from the definition itself, lead parlite gneiss will be the correct answer. Now as far as augengneiss is concerned, augengneiss are those gneisses that have augen structure. Augen structure means eye-shaped grains. Okay, and these grains are predominantly of feldspar. So augengneiss is also not the name that shows an intimate mixing of igneous and schistose material. So the correct answer will be litparlitgneiss. Next question is, development of foliation in metamorphic rocks is mainly a function of. Okay, so foliation is a texture in metamorphic rocks, and it is indicative of regional metamorphism. That in regional metamorphic rocks you will get a foliation, and we have discussed in question 57 that regional metamorphism is found by both temperature and non-lithostatic pressure. So development of foliation in metamorphic rock is mainly a function of temperature and non-lithostatic stress. Now fluids and temperature, this will not be correct because pressure is not involved in this option. Fluids and pressure will not be correct because temperature is not involved in this option. In the option third, there is lithostatic stress and temperature. Now lithostatic stress and non-lithostatic stress. So lithostatic stress is not responsible for any type of deformation in a rock. Okay, and this will not produce any metamorphism. Only the thing will happen is volume change in under lithostatic stress. Non-lithostatic stress is responsible for metamorphism in a rock, and this is also responsible for, this is the condition which is present in regional metamorphism, and foliation are present in regional metamorphic rock. So the correct answer will be non-lithostatic stress and temperature. Thank you guys for watching this video. If you have not subscribed my channel yet, please do subscribe and like the video and share among your friends. Thank you.